go ahead and get started so we have a little bit more time if we need it. And I'm recording, so those who are not here yet, they'll be able to see it. Nothing too new, except, again, I do have the solution videos completed now. Hopefully you saw that announcement last night, if I sent it. Sometimes find I write the announcements, but I don't send them. So let me click here. So unfortunately, I guess my microphone ran out of juice or something, and last class session, the audio went out partway. So I remade the videos that we worked through for 3, 8, and 9. I completed 10, so they're all here. You can just click on them, watch them in the window, make them larger, go to YouTube, whatever. And then 12, 15, and 19 are there. So these are sort of like a model solution, a model questions. And if you know these 7, basically all the things you're doing in there covers everything that'll be on the test. With that being said, it's still good to go back and do more. It's not, okay, let me just know these inside and out. Go ahead and know them inside and out or follow through them, but then apply the techniques on new scenarios, on new ones. And I think I'm hoping you'll find that maybe these templates, which sort of give an overview of the process, might help, because there's a lot of pieces. Some of them are just a small step, but if you miss that step, then it's, you're stuck. So hopefully those are helpful, giving you that overview. And again, breaks it down to basically 7 things, and not quite, because even some of the things you're doing a second derivative, and then we use the second derivative again in something else. So, that list that is not here, but in the review resources, is a good list to kind of be able to just kind of pull it up. See, first exam content. If you pull up this Word document, just maybe go through and check off these. Do you know what each of these are? Are you able to kind of do each of those? Then you're in good shape. But you might not know what these are, but you'll see that all of these are embedded in those 7 questions. So, and again, I went through the exam and I said, you need to be able to do all these things. And then I looked at the review and said, here's 7 questions that have all those things in there. And then there's additional ones to do practice with. Homework is good too. Remember, but even I was reading over the notes from the syllabus from the coordinators, and they say the best way to prepare for the exam is to look at that review. So focus on that. There's a few homework problems that are not going to be on the test. So, if you're stressing about this particular homework problem you can't get done, if it's not on this list, don't worry about it. Don't stress about it. Put it aside. Focus on the test, because that's where all the majority of the points come from for the class or the exams. I'm going to move the homework till Sunday night, so that should hopefully release some stress. Get as much as you can done. There's ones that are, that are like this. Those are good to do. Go ahead and give them a try. But there are some that, again, for the exam for Friday, this and the review that the coordinators have provided is the best way to prepare. Watch the videos. You can do that sort of passively. They're on a playlist. You could almost just get some popcorn, watch it like a movie if you want. Just watch it. Maybe I've had students who said that's exactly what they did. They put in a playlist and they just kind of watched it a few times in the background, and that got them the process. Take the extra step and then work a few on your own. Maybe even the same ones, but don't look at the notes, and see if you can do, because then once you get that, then try a new one, But take the time, invest the time. I know you've already been investing time, but do it so that you're ready to go Friday. Because these are, again, the way we do it, 70% of the grade comes from the exams. So you need to do reasonably well on them. All right. Like I said, I don't really have a plan for today. I just showed up, rolled out of bed, said, I'll go to class, see what you guys want me to do, right? What would you like to see? Yeah, that was a tricky one. So let me pull up where I got it here. Here's the review. So an extreme value theorem. So that I've done 19. How about if we do, so notice 20 and 21 are just a repeat. 20 is a little more complicated. It's got some squares in there, which, well, we got squares up there too. 20 or 21. How about I work a new one? I'm recording this as well, so it gives you a second look. 20, 21. Which one? 20. All right. Yeah, it's a little bit harder, maybe a little closer with the squares. So what I'm going to do is I'm going to copy this. If I can, oh wait, I might not be able to do that while I'm recording. Can I do that? Let's see. Oh, maybe I can. Okay. I'm going to 20, right? Yeah. I'm going to put it in a Word document so it's a little easier to get through. And insert. Good. Okay. What I'm going to do is, again, the way I would suggest to do this a few times, let's pull up the template. If you haven't used it yet, that's a good way to go because it's going to give us an overview. I'll review the template so you can get the template from the solutions guides. Maybe I should have put them here too, but we'll figure it out. So this is the extreme value. And the good thing of practicing this extreme value is you're actually practicing many of the skills you're going to need for it. It's going to help you with probably about 4 or 5 of the questions on the exam itself because of all the things that's involved in it. Extreme value or the Lagrange multiplier, the one with the lambda. Is that the one? Well, we'll do this one, and then the one with the lambda is that's the Lagrange. So we'll do both. Okay, so we'll do an extreme value theorem here. Let's see. Let me download that. I've got it somewhere, but just make it nice and easy. Okay. And I'll kind of do it. This is how, of course, at home I've got a larger monitor, but I just put them side by side. So, and again, if you haven't used this template, please do. The exam will be using templates similar to this, not a little bit different, but you're going to be expected to fill in a template basically. You're going to be expected to do all these 3 steps. In fact, I even took the instructions, the way I wrote the instructions from the test. I think I'm anyway. If you get used to these, then you'll say, oh, that's all they ask. What they'll change is what the functions are. It's pretty much, but so this is a good one to have. Let's see, we're okay there. Okay. I think let's see if this draw works. I think this one, when I start writing in here, so I can kind of get rid of this screen. So we've got our function. Yeah. I don't like that. Well, rather than rewriting it, oh, this one's okay. this constraint, drawing the constraints on this one's going to be a little challenging, okay? It's got x greater than 0, y greater than 0, and then it's got this, which is a line. So that's going to be actually some kind of a diagonal, so it's going to be a triangular region. I'll help you all out a little bit. Maybe I'll get a little trouble for this, but the region we're going to deal with on the test is a rectangle, like the last one, okay? A rectangle. Those are much easier to deal with because we can draw them. This one is, we'll spend 20 minutes just drawing the constraint region, okay? So let me go back and see. I could just change the constraints and work it a little differently, but this is this one is a sort of an extra challenge. So is this one because it's going to have the parabolic. So we're just going to do a constraint. So let me go back to that one. It's okay, but let me just change the constraints on it. Let's see, let's go with that. This. So let me so that it's closer, because I just want you to focus on the test. I don't want to distract you into doing a bunch of stuff that we're not going to be on the test. Might be helpful. It'll be in the homework. You'll work with those. So let's change the constraints to something like 0 is less than or equal to x is less than or equal to 5. 0 is less than or equal to y, which is less than or equal to 7. Okay, so that's the kind of constraints you'll be doing on the exam. When we come over, there it is. So on the template, to draw that region that we're talking about, we just go, x is going from 0, it's from here, to 5, it's to there. Y is going from 0, it's from here, to 7, it's up here. So I'm going to draw a little rectangle. And unlike the other constraint stuff where we said the feasible region, don't shade it, shade the other stuff, just made it easier. This, they want you to shade the feasible region. So this is the region that the shape exists in. So we'll shade inside. So it's kind of a little backwards, but it's because we're not really expecting you to graph everything else. So far, so good. So your constraints are going to be a rectangle. X is between two numbers and usually 0, something like this. We've got our region. What we have is the function is a 3-variable. Remember that function is z. So we've got x, y, and z. It's a 3-dimensional shape that lives in here. So it's actually going to come out and maybe go through the screen. But this is our boundary, the rectangle. And inside here is the interior of whatever's going on. But remember, it's in 3 dimensions, so it could be coming up and down. So there's 3 places where a maximum or a minimum could exist. And remember, this is extreme value theorem. We know we're going to have an absolute max and an absolute min. So we're going to have one of each somewhere. That's what the theorem says. So we check the corner points. So that's going to be the easiest one to check because they're right there. So I'm going to label those. So over here, we've got, this is 5, 7. So this point here, 0, 7. This point here, 0, 0. And this point here, 0, 5. Okay, so those are our corner points. So we list them over here. Oh, thank you. Keep me honest. So it's 5, 0. X comes first, then Y. Okay, and then list them all over here. Then you can plug them into the original function to find the z value. I'll wait till the end to do that. That's sort of what the instructions say. Okay, so that's the first one. So that's A. We just did A. Okay, so many points. B, list the critical points that lie within the region. Within the region, what we need to do is we need to find the critical points. And we do that by taking the partial derivatives and setting, partial derivatives. Let's see if it'll let me write now. So the partial derivative with respect to x and the partial derivative with respect to y, we're going to take those, set them both equal to 0, and find the place where there's a simultaneous solution to that. Now this is, again, it's a little complicated, but this first part, to take the, you could also multiply these out with algebra if you wanted to FOIL them out. It might make it easier, but otherwise we need to use the, well, we will need to use the chain rule. So I'll go ahead with the chain rule. So this is, we're taking a derivative with respect to x. So the 2 comes down. So this is the outside, x minus 10. And then it's to the first power. And then we take the derivative of the inside, which is, the derivative of x is 1. So it gets multiplied by 1. So that's it. We do the same thing with this next one, y minus 20 squared. But since y is a constant, this whole thing is a constant. So its derivative is 0. Okay. So the second term up here, its derivative when we're taking the derivative with respect to x is 0. And 150 is a constant. So when you take its derivative, it's 0. So that's it. Not too bad. Not worth foiling out. We okay with that part? Taking that derivative. So these are also good practicing, be able to take the derivative of different types of things. Because we didn't teach it here. We taught it in 210, and we're expecting you remember everything freshly from there. So we okay with that, though? Okay. Let's do it again with the y, and we'll see, okay, this first term, x minus 10 squared, that's got an x. It's a constant. Its derivative is 0. So all we got to worry about is y minus 20 squared. Taking the derivative of the outside, the 2 comes down. Y minus 20 is on the insides, and it's to the first power. Chain rule, we take the derivative of y, which is 1, so we multiply by 1, but we don't have to, so that's it, right? So those are our derivatives. We set them both equal to 0. And so this is going to give us 2x minus 20 equals 0. Add 20 to both sides. You get 2x equals 20. Divide by 2, you're going to get x equals 10. Oh, that's pretty cool. This one, you get 2y minus 20. Wait a minute. Oh, 40. I asked, well, how did I get 20 the first time? It was 10. Okay, I did that right. I just got going too fast. Thank you. But I got you guys to cover my back, right? Let's see. Sometimes these. Okay. 2 times y, 2 times 20 is 40. Good. 0. Add 40 to both sides, so we get 2y equals 40. Divide by 2, we get y equals 20. So that's it. That's the point. 10 comma 20. So that is a critical point. And so we come over to this side. We go ahead and list that. And again, at some point, you'll plug those coordinates into the original function to get the z value. And then all we're going to look for is which one is the biggest z value. That's the maximum. Which one is the smallest z value? That's the minimum, okay, at the end. So this is, not too bad. And then this is maybe the harder part, is we need to list the critical points on the boundary. So this was the critical point in the interior, right? Wait a minute. Oh, I know the problem. It's actually not even, in this problem, we could ignore it, right? Because 1020 is not in our boundary region. It was probably in their boundary that they had. So sometimes when you switch a problem, you mess it up. So if this was the problem, you say, oh, wait, 1020, it ain't even in the region. We don't even have to consider it, right? But I should have made a bigger region, and I would have had it, but 1020. So come back here, that's it. You know, we know where it is. It's not in the boundary. So for our problem, we can say, don't worry about it. Okay. But the boundary regions now are going to be along these vertical lines and these horizontal lines. So there's 4 boundary that there potentially could be some max or mins. So the way we do that, see if I gave myself enough room, is we come back and we plug those constraints into the original function. So maybe I don't know if I'll do all of them, but let me do one of them. And then, because I want to try to get as many possibilities as possible, not necessarily the minutia. Okay, so let's take, so basically there's 4 things we're going to try out. This will work. We're going to have x equals 0, that's a vertical line. X equals 5, that's a vertical line. Y equals 0, that's a horizontal line. And y equals 7. So those are our sort of the boundary, right? The boundary lines. So what we do is, let's take this one, x equals 5. What we do is we put f of 5 comma y. So we know 5 is going to be the x coordinate. Now we look for a potential coordinate for y. And so we plug this 5 in for x. 5 minus 10 squared. We're probably going to run out of room here, so I'll stretch it a bit. Plus y is still y minus 20 squared, plus 150. I'll just put it up here, right? 5 minus 10 is negative 5. Squared, you get 25, positive 25. So add that to the 150. And so now our function is y minus 20 squared plus 25 plus 175. Now that part's not so important because what we need to do next is we need to take the partial with respect to x and with respect to y. Do you see here with this particular function that if we took the derivative with respect to x, we're going to get 0 because there is no x? Okay, so it's all a constant with that. So we don't even worry about that because x is not 0, it's 5. But we take the partial with respect to y, and that should give us a y coordinate. So we can kind of say, okay, partial with x is equal to 0, but it's not 0, so this gives us no information. Partial with respect to y, just like we did last time, the 2 comes down. Oops, sorry. And then it's to the first power. So y minus 20 there. And then the derivative of y is 1, so times 1. So let me kind of come down here. We set this equal to 0. And solve for y, which is basically the same thing we solved here. And we've already got that y was equal to 20. So again, solve. And so there's a boundary potential maximum or minimum at the point 5, comma 20. So notice how the boundary line gave us 1. Unfortunately, again, I messed around with the constraints and it's not the problem. That's not in our boundary, is it? 20 is like up here, and this is where we're contained here. So again, we're probably not going to get any of those, but on the test, they will set it up so that the constraints fit the problem, and you would get probably a point somewhere along here, okay? You get all those points, and then you evaluate. So I'm going to go ahead and do it. So 520 is another potential. Get all the z values, and we okay with doing that? Maybe I'll do one of them. So f, let's, which point should we use? How about 1020? That would work, because that'll be actually one of the problems if you actually work through this, and the solution guide will give it to you. So you plug in 10 for x, and it's going to make it nice. 10 minus 10 squared plus 20 minus 20 squared plus 150. So we're just evaluating it at the point that we found. We get 0 plus 0 plus 150. So this z value is 150. Now, again, if that ends up being the biggest z value, that would be our maximum. If it was the smallest z value, it'd be the minimum. If it's in the middle of a bunch of other numbers, it's nothing. Okay, because that's all we're doing is absolute max, absolute min. Do that with each of the points, and then we just figure out which one's here. And that's extreme value theorem.
For z values, let's say we had a lot of the same values, how would we be able to identify our minimum?
You still the biggest one. Now, if you had two, I think I was doing one where there was two minimum values that were the same, or maybe two maximum values. You still only have, say, one minimum, but it occurs at 2 points. So that's just kind of something we ran into in 210 as well. So you would list both of them. On this, I would pick it. As long as you listed one of them, you'd be good. But yeah, you may have 2 points, or even you could have 3 points where the minimum occurs, but it's really one minimum value, right? Like 10, negative 10 maybe is the minimum value, but it occurred in 2 different points. You could list both points. No, because you can't. I mean, that the values are the values. We're constrained in this region. The theorem just says there is a place where you get there is a minimum value you will get, and there is an absolute maximum value. But it doesn't say that it only happens in one place. But you will not get, so yeah. Yes. I made it up because I didn't want to use, I was telling you that on the test, this is the kind of region you're going to draw. It's fairly easy to draw, this kind of region. This region would be difficult. These two are not bad. They're greater than, but drawing this line might be a little bit of a challenge. I mean, you could do it with your calculator and see, but you're going to get a sort of a triangular region. And I just didn't want to throw something into the mix that, it's not even on the test, right? I want to focus on that test, and I want to give you what you want. So I made up something new, and it doesn't fit the problem very well. I should have made it bigger, but what I want you to see is the method. Yes, sir.
The region always going to be a rectangle or not?
Yeah, I know what's on there, so I'm letting you know that's showing up, or at least listening to the video. I just, because I want you to be, what I want you to be able to do is focus on the overall process. Now they're going to provide this, and I just want it might even be 5 and 7. I might, because I looked at it, maybe that's what it is. Probably, but it's something similar. It might be 10 and 50. But whatever it is, draw the rectangle. That's all you're going to have to do. So don't let that part stress you, because that's just an algebra thing. Know the method. But again, it's set up like this. So if you've at least looked at this template, you should kind of know they're going to ask these questions. So just do it in the order, list the questions, get the z values. It'll follow through. So I think the test is very valid because it does those things. In 210, sometimes they would set these up, but they asked questions in kind of wrong orders, and it actually made it harder. These guys, I believe, makes it easier because you just follow the template and you're going to be fine. And then I built the template off of what they provided and how to work it. So yes, sir. Oh, thank you. Yeah, I just, again, not really paying attention. Please pay attention when you're taking a test. Unlike me, I just kind of, don't drive and eat too much either, because I get distracted, especially yeah, sometimes I'm driving along and I go, oh, I don't remember what I've been doing for the last 5 minutes. That's not good. I should get off the road. Okay, be good with that. Extreme value theorem. You want to see a Lagrange multiplier? And again, I'll try to focus on what part ends up being maybe the most challenging. Let's go for link page. Okay. So let's come back. Lagrange. Here's Lagrange multipliers. Let's see if that's. That would be more challenging, but again, I want to do one that's similar to what we've got, and they want to test you that you know how to use a Lagrange multiplier. So for this one, they don't provide. They give you the both functions. Okay, so let's take that one. That's what I feel. Exams should be something that it shouldn't be too much of a surprise. It's the Lagrange multipliers. I'll go ahead and just read this. Don't save. Lagrange. Download this one. And again, if you haven't looked at this yet, download it, have it, at least look at them. You may not, want to use it, but now the exam, they don't give you something like this. No, you don't get the templates on the exam. Sorry, I thought I made that clear. You use them to learn the process, but you've got to practice that process a few times. Use them for the homework too. I think that'll be helpful. But you've got to learn it, and you're not going to get this formula is not going to be provided for you. But you just got to remember, okay, it's the function minus Lagrange times the g function. So you got to remember those things. Those things have to be there. There's no formulas, and templates can't be used. No, I wish, but now the last template though, it's embedded in the test, so that one will be there. The Lagrange multiplier, when they ask the question like that, they don't give you the step-by-step. So they just ask the questions, and I came up with these simply because I needed to. Okay, so let's make this maybe a little smaller. You can kind of still see that, right? Okay, I think on this one it's small enough I can use my other tool. Where is it? My Epic pen. Okay, Lagrange multipliers. And again, I'm just going to kind of focus on. So first out, we need the function. Again, this template is not provided on the exam, but it's a good little, yes. Yes. Well, no, this is I did 15 on the video. This is 16. So it's a little different. Numbers will be different, but it should hopefully come through pretty clear. The other function we're given is not equal to 0 yet. We need to make it equal to 0 before we put it here. Okay, so it's equal to 10 right now, so I'll subtract 10. So it should be x plus 2y minus 10 equals 0. So that's our function g of x. Y it's the constraint x plus 2y minus 10. So that's the first critical step to take. If you don't take that step, nothing else is probably going to come through, because you're going to have it equal to 10, and for this thing to work, this has to be equal to 0. Okay, so that's the first step. Next critical step is be able to set up the Lagrange formula, to the function. Okay, again, it won't be provided for you, but that doesn't mean you have to, practice it, but get it so that you can remember it. And it's not too bad. Okay, it's the function. That's my x squared plus y squared. And you could put a parentheses around it if you want. But then we're going to subtract. What are we subtracting? Lagrange. And then you could use the L if you want. It's remember that part's going to, but it's a Greek letter, the Greek L, I guess, or lambda they call it, times the function g of x, which is what we have up here, x plus 2y minus 10. And yes, that will distribute through. What is lambda? It is a constant, but we don't know what it is and we don't care what it is because we don't need it. But we're going, because by the time we're done, it's gone. Now, some applications you might need that lambda because, but for these, what we're doing, we don't. So this is our function. We're going to take the partials with respect to x and y. So all we've done with the Lagrange method is to set it up this, and then now the rest is the same. We're going to treat the Lagrange function as our function, and there we go. And then, so we're going to take the partials, set them equal to 0. The thing is, we have this thing equal to 0 as well. So at the same time, the constraint and the partials are equal to 0. We use that to first solve for lambda, because we've got to get the lambda out of there. And then we substitute in, and then we solve for either x or y, and then we substitute that into the constraint. And so that's how that's going to work. And then we come up with one or more points. Okay, so the partial with respect to x. Now I would go ahead and distribute the lambda. I'm gonna rewrite it over here as x squared plus y squared. It's coming back on. This is the other critical stage when you distribute. Watch your negatives. You know, that's one of my hardest things to do. And then I'm going to get a minus 2 lambda y, and then a plus lambda 10. Now, since we are going to take derivatives, that in 1 lambda 10 ends up becoming 0 anyway. And this is, what's it? Whoosh. Did it really just erase? Let me see if I can remember what I had. It erased all my work. Great. X squared. So I think that after I distributed, this is what we have. I got that right? Yeah, we had a minus 10 come plus 10. Okay. Take the partials. Partial with respect to x, x squared becomes 2x, right? So that's its derivative. Derivative of y, 0. Derivative of negative x lambda is going to be just negative lambda. X is 1. Derivative of 2 lambda y, 0. Derivative of 10 lambda, 0. Okay, so a lot of things start dropping out. Keep going and I'll talk it through and it should hopefully flash back. Partial with respect to y, x squared is 0. Y squared becomes 2y, it's its derivative. Lambda x becomes 0 as a derivative. Derivative of 2 lambda y becomes minus 2 lambda times 1. And then derivative of 10 lambda is 0, because that's a constant. So we've got these. Set each of these partial derivatives equal to 0. So once you've got the partials, 2x minus lambda equals 0. 2y minus 2 lambda equals 0. Solve one of them for lambda, and I would choose the easier one. I think this one over here, if I solve this for lambda, add lambda to both sides, and you get 10x equals lambda. Maybe I should change colors. So I'm solving for lambda, and then what I do is I substitute 2x in for lambda over in the other equation. So I'm going to write 2y minus 2 lambda. I'm going to rewrite that as 2y minus 2x. Oh, wait, 2 times 2x equals 0. So I'm going to have, let me write that up here, 2y minus 4x equals 0. So that's using that second one. What I do now is, because what I'm going to come back to this constraint function, which was x plus 2y minus 10 equals 0. So I need to solve this equation for either x or y. I believe it'll be smoother if I solve for y. So I add 4x to both sides. So I get 2y equals 4x, right? And then divide both sides by 2 gives me that y equals 2x. So notice a lot of this is just algebra stuff. So I'm going to make a substitution in my constraint function. I'm going to replace y with 2x. And I'll do that over here. So I'm going to get x plus 2 times 2x minus 10 equals 0. So notice we end up using 3 parts. We use both the partial with respect to x, partial with respect to y, and the original constraint function. This is going to give us the critical points. And then I'll have to have them come look at this. I think it must be in this cable. Is having problems, overuse. Then once we have a critical point, we plug it back in to the function, and then since there's only one point, right, it's where we've got horizontal tangent lines, it's got to be a max or a min, and it's telling us, the problem is telling us to find a minimum, so we'll assume that what we found is a minimum. We don't have to go to a second derivative test or any of that kind of stuff. We just find it. So, oh, great. Now you see why I like to, when I work from home, I never have these problems. But my internet's real slow, so then uploading videos is not so good. Let's see. I'd lost. Let's see if I can get it back. Oh, never mind. Still need to write with the right side of the pencil, not the upside down. Okay, so sometimes I'm my own worst enemy. Okay. So now we've got something with just x. That's, that's going to give us x plus 4x minus 10 equals 0. So we get 5x minus 10 equals 0. Add 10 to both sides. 5x equals 10. Divide by 5. X equals 2. So that's one. That's the x coordinate. How do we get the y coordinate? Yeah, go back to any of them, but this one would kind of be the nicest one because we've got y equals 2x. That's plug in 2, y is 4. Good. And so that's our point. All that's left now is to plug it into the original function, not the lambda function, just the f function. So we're going to have x squared plus y squared. That's all we got to do. So we're going to have 2 squared plus 4 squared. So that's 4 plus 16, which is 20. So our z value is 20. And so our final answer is a triplet, x, y, and z. And that's the minimum. And again, because they ask for a minimum, it must be the minimum. And in these problems, we don't have to go proving what it is. We'll get 1 point and do it. Now, I guess it would be possible to get multiple points. If we've got more than 1 point, I guess we plug them in, and we again, if they want the minimum, we would take the one with the lowest z value. If they want the maximum, we take the one with the biggest z value. So, but a lot of times on these, the way they've got them set up, we only end up with 1 point. So it's a technique. We just want you to be able to do it. So again, main thing is get G equal to 0, and so that they don't give it to you equal 0, so just subtract the number over or get it, equal to 0. And then it's the function you're given with lambda times the constraint, minus lambda times the constraint. Subtracting off the constraint. Okay. That gives you your new function that you take partials of to find the critical point. And then you use those partials, partial of x and partial of y, along with that constraint function, because they're all simultaneous. The key part is, and that's what I messed up in class, is you have to solve for lambda first. Take that, substitute that in, solve for x or y, whichever one you want, substitute that into the constraint. You got a question with one variable, solve it, and you're good. You get that, plug it back in, get the y, plug that into the original function, you got your z. Yes? Yeah. 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 No. Now, in the real world, there are examples, but they would deal more with construction. We're giving more simplistic ones. Yes. 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 Exactly. Yes, sir. 14. You got it. And remember, I'll be here if you want to stay around. I've got the hour of office hours. Probably not, because there's a lot of times where they're. I mean, I don't mind, but what I'm going to say is, if you have questions, send me an email. After this class, I usually go home and do work at home. I can make a video solution, and I'll post that. And then it will not only help you, it'll help everyone else. I think those will be better. I've tried doing, it's not that I don't want to do office hours, they really don't work out very good for recording. 14, let me see if I can get there. Here. Oh yeah, that's the thing I don't like about this one. I gotta just delete the whole thing. There we go. Substitution method basically is you take the z, you put in for the z, you would put the 5y. And then we don't need to use the Lagrange multipliers. We could have done that with this one as well. We could have solved for y, plugged it in, and then we wouldn't need to use Lagrange multipliers. The thing is on the test, they'll tell you can do that to check your answer, because it's actually easier. But you won't, it says, unless you use Lagrange multipliers, you won't get the points. They want you to be able to do it. So substitution is actually an easier way to do it. If it works, if you can solve for it, you just plug it in, and now we've got two variables, and we don't need Lagrange multipliers here. We take the partial of x, and it's going to get a solution. So it's easier, but they won't. This is not on the test. Substitution. It's just okay. You can use it to check your answer, but they want to see the Lagrange multiplier. So it's okay if we, okay, but that otherwise, yeah, that's what. No, because it's easier than the Lagrange multipliers when you can do it. But they were nice enough to give you a Lagrange multiplier where substitution would work. There's some Lagrange multipliers where you have to do it that way because substitution doesn't work. But they gave you one that is sort of in the middle. Substitution will work, but they says you have to use Lagrange multipliers to get the points. So I just gave away. That's one of the open answers. So there's 3 questions. I just told you, again, you beat it out of me. You waterboarded me. There is a extreme value theorem one that basically gives you the template too. So do that one. There is a Lagrange multiplier one that is in the open answer. So that's 2 of the 3. I don't remember. The other one wasn't too bad. It was maybe like find the partials or something. 17. I could, but and actually that's what they asked, is to put it all together. But I'm telling you, on the exam, they put it together for you. So the part that you might probably are stressing about is the word problems, getting the constraints all set up. You won't have to do that with this. They test that earlier on. And so like which one is that? That's, I think it was 12 where you had to set up the constraint. You had to set up the feasible region. So there's a couple ones that I walked you through. They'll do that. But for this, you won't have to set up the constraint. I mean, you could, it's good practice maybe, see, but you can look at the answers of what they've got, see if it works. And if you want to stay for office hours, maybe I will, but with just 5 minutes, this is going to probably take us a little bit of time. And if you want to just focus on the Lagrange multipliers, stuff like this is what they'll give you the two functions. Okay. So just do well, spend the time. You basically know what's going to be on there. Stuff like those 7. Practice them. Get the skills down. Maybe make some flashcards, and then make sure. Lagrange know the vocabulary because that's what's going to be used on the exam. But look at the templates. I kind of tried to build it as best. The review is very close. They basically take those questions and revise them slightly with different functions, but the wording that they use, coordinators made the review, the coordinators made the exam. There is one with taking the derivative of e to some power, but it's a multiple choice one, so you just have to be able to recognize. Okay, you should be able to do it, but also I moved it so that there was 2 and they let me change one, so I took the one that you have to do manually out and put in a simpler one. The one with the E is a multiple choice one, so you have to be able to recognize, and hopefully you can at least recognize it. So good. I think, I want you all to do well. Remember, we have 3 exams, and once we're done with this content's gone, and we kind of go into a new set of stuff. Second exam won't come over any of this stuff, nor the third. We'll never see this stuff again. Final is not cumulative. It's just over the third stuff. So it's like 3 separate little courses. It's like yeah. It's just because it's too diverse to try to come back and think about Lagrange multipliers when we're doing matrices. No, it's just like, whoa. Yeah, matrices are actually pretty fun. What's that? It is different. I mean, sometimes it builds off of the concepts, but you won't have to use a Lagrange multiplier. I think I haven't looked at it, I'll just be honest, but this is the heavy calculus part, and then we move into other stuff that are more algebra and other stuff. So, and technology-based stuff. Like when we get to matrices, a lot of it's just learning how to use your calculator to put stuff in and get it. We'll get there, but you know what you need to do. So we've got an hour. We'll go ahead. Since I started class 5 minutes early, I'll start office hours 5 minutes early, and those that need to head out, you're welcome to do that. If you have questions, again, email me. I'll do my best to get something posted, recorded, and up. And again, I will work any of these. I just didn't want to. Yeah, I'll put an announcement about that, and I don't have a place to put it yet, but I'll put it, and you just take a picture and upload it. And yeah, thank you. Yeah, you just work. Just show me what you've worked through. So all you got to do for the quiz points is take a snap of what you did to prepare for the exam. Yeah. You don't prepare for the exam, it's not going to help you because you need it. So just prepare. Yeah, I'm not even going to look at it just to be. Let me take this thing off.